Okay, so we've used logs just simply to get some answers, but now we're going to look at them to solve equations. So for instance, we don't need logarithms. If 2 to the x equals 8, we know the answer must be 3 because 2 cubed is 8. So we don't need to use logs at all. But what about if 2 to the x equals 7? Now obviously for the visual learners, all exponential functions look like that sort of shape in that brown shape, and it's going up to the right. So what the question's saying is, if the answer was 7 and you came across and read that down, what would the answer to x be? And again, I've said over here, we know the answer must be between 2 and 3 because 2 squared is 4 and 2 cubed 8 and 7 is in between, so that means it must be in between 2 and 3 and closer to 3 than to 2 because 7 is closer to 8. So here's how we do it. So come across when you're ready. So what we do is we say 2 to the x equals 7, and then what we do is we take logs of both sides. So just put the word log in front, and then we use the log laws. So that power comes out the front, so x log 2 equals log 7, and that's just a multiply, and to get rid of multiplies you just divide. Now I haven't put any base there, but on your calculator it's base 10. So on your calculator log 7 divided by log 2 is 2.81. That means if you had 2 to the power of 2.81, you'd get about 7. You won't get exactly 7 because I've rounded, but you can check on your calculator. You've all got the x to the y button, so if you just go 2 to the power of 2.81, you'll get about 7. Okay, so that's why we use logs to solve equations. When you're ready, come to the next slide. Okay, so we're just going to go through about 8 examples and just getting progressively more complicated. Okay, so the next one is the power is not just a simple x, it's a little equation in itself. But basically, if you look at the previous slide, when we had log 7 and log 2, okay, when we had log 7 end up being divided by log 2. So when we look at those numbers there, it's just log of the answer divided by log of the base. And that's a shortcut we can take. So that answer, the power, will equal log of the answer divided by log of the base. And on your calculator, to a few decimal places, you get 2.822. So that's still 2x minus 1, and then take the 1 across by adding, and then just at the end just divide by 2. So that gives you the answer of 1.91. And again, there might be some rounding errors, but that's, I'm hoping that's correct, the 2 decimal places. Okay, so copy that down, and when you're ready, come across. Okay, so now the next one is we've got x's on both sides. Now I'll show you the traditional method, then I'll show you the log method. So the traditional method would be, well, 2's and 8's have a common base of 2, so 8 is 2 cubed, okay, 2 cubed is 8, and then power inside and the power outside is a multiply, and then once you've got 2 to the x minus 1 equals 2 to the 3x, you can forget about the 2's because the base is the same, and then you just solve the equation and you get minus a half. Okay, so that would be the way you did it when you were in year 10, but now we can use logarithms. Okay, so same idea, put the word log out the front, okay, so log of both sides, and then the power, this power, comes out the front, and that power comes out the front. So then we've got x minus 1 log 2 equals x log 8, and then in the way I'm doing it, the x comes across by dividing, and the log 2 goes across by dividing, and then log 8 over log 2 equals 3 on your calculator, just using log 10, and then I've cross multiplied that back again, so that becomes 3x, and you end up with the same answer, because it has to be the same answer because it's the same question. Okay, so have a look at that as a method, and we'll go through some more complicated examples when you're ready. Okay, so this time there's no connection with the bases. 4 and 7 have no connection, but basically what we can do is, these are the indices, so it'll end up being x minus 1 divided by x plus 2 on one side, so the left over the right, and then we go log 7 over log 4. Okay, there would be a lot of steps we could do to show you the same thing, but it ends up being the same. Okay, then on your calculator, again, I'm not going to keep putting 10s, but we're using base 10 on calculator. you get 1.404, and that's still x minus 1 over x plus 2, and then I've cross-multiplied off the denominator to make it go the other side. Then I've expanded out the brackets, and then I've got x's on both sides, numbers on both sides, so I take x one way, numbers the other. So I'm taking the x across to 1.4 because that's bigger, so you go the opposite way, you end up with that equals that, and then divide, and you end up with this really neat answer. Now I've made a note over here on the right hand side that we could have put the x plus 2 on top of the x minus 1, but then log 4 would go on the top. So it doesn't matter which way you do it, you'll end up with the same answer. Okay, so they're getting complicated, but that's what it is at this level when you're ready to come across. Okay, so the next one, I've got logs, I've got indices with different bases, multiplying equals a number. So again, first step is take logs of both sides. Okay, now log of 300 equals a number, but we're not going to worry about that at this stage. And now the log law with multiply means you've actually got an add. Okay, so when you multiply, you actually have an add. And then the next step is bring the powers out the front. So that number goes out the front, and that number goes out the front. So you can see what I've done then. And then over here, what I've done is I've expanded out the bracket. So x times log 3 and 1 times log 3. Okay. And then what I've done next is I've got some x's here and I've got some x's here, and so I've factorised. So I take x out of both and end up with log 3 plus log 2, and then to get this log 3 to go away, I've just subtracted on the other side, and then notice we've got a minus, which means you've got a divide, and over here notice I've got a plus, so I have a multiply. So I end up with log x log 6 equals log 100, and so it's just log 100 over log 6, which on your calculator is 2.57. So again, it's getting harder, but that's the level we're looking at when you're ready to come across the next slide. Okay, so we've got 2 or 3 more examples to go. So now we've got indices, x's all over the place. So just follow through. Okay. First step, take logs on both sides. Next step, break up the multiply with an addition, and then bring the powers out the front. Okay, and then bring the x's all to one side. So this term here, okay, that's got x's in it, so I've got to bring it across the other side, and then log 5 goes the other way. And then, strictly speaking, I could make this a single number if I wanted to. Okay, so if that was going to be, I don't need to, but what I've done is I haven't done it in this step, and I've just divided minus log 5 divided by that. But if you were going to simplify that, just for interest sake, it'd be log 5 plus log 2 minus log of 11 squared is 121. So strictly speaking, if you wanted to, it'd be 5 times 2 is 10. So strictly speaking, that number is what you would divide by, but I wouldn't bother. Just put it in brackets and just use your log button on your calculator. But strictly speaking, if you wanted to, you could simplify that to a single log answer. Okay, when you're ready to come across. Okay, so now we've got what looks like a quadratic equation because we've got something equaling 0, and you'll note that that's like the simplest term, 2 to the x, even though 4 to the x is also looking simple. Because 4 and 2 have something in common, we're going to make the lower number equal to a new variable, any letter you like, but I'll call it a. And what I've done is, looking at this complicated 4 to the x, okay, 4 is 2 squared. Now, if I've got 2 to the x, I've got same as x to the 2, okay? 2 times x equals 2 times x, it doesn't matter order. But now what I've got is I've got a to the power of 2 inside the bracket. And then what I've got now is a quadratic. I've got a squared minus 5a plus 6 equals 0, then factorise, which you've been doing since year 9 or 10, and you get 2 answers. And once you get those 2 answers there, then just bring back 2 to the x, and then just solve. The second answer is the easy one, 2 to the x equals 2, that gives you the easy answer 1. And the first answer is the harder one, log 3 over log 2, which is about 1.6. Okay, when you're ready, come across. Just a couple more with inequations, less than and greater thans. Okay, so the first one, okay, so we just start off the same, pretend it's an equal sign, and because log of 2 is a positive number, we don't have to change anything. Okay, so if 2 to the x is greater than 5, then x is just greater than log 5 over log 2, which is greater than 2.322. So there's no problems there. But in the second one, when you look at that base there, okay, so we've got a less than an equal sign there, but what we have to do is, because we're going to divide to get rid of the log of 0.5, because log of 0.5 is a negative number, we've got to change the sign in between. So log of 0.5 is a negative number, and we know that with inequalities, when dividing by negative numbers, you've got to change the sign in between. Okay? And then that will give you still have log 1.4 over log 0.5. That doesn't change, but we have to change the inequality in between. Okay, and the exercise number is still in the same textbook, but don't worry about questions 10 to 12. Okay, thanks for that. Bye.